So that means now I should be hearing people actually talk. And now you have a cheat sheet to look at if you need to. Home was number 29 and 30. They're down here. I have a feeling you guys aren't listening to my directions. 29 and 30 are what we're working on right now. So when we talk about chance of drawing a diamond, remember how many diamonds there are. You can check the cheat sheet. Be careful on 30. What's weird about 30? How do they change the deck? On 30, you might want to highlight this. They take out all the aces and they take out all the twos. So now their deck of cards is different. So be careful. They take out all the aces, take out all the twos. You get some answers there? You get some stuff written down? Guys, I'm giving you time to get your homework done with your partners right now. Alright, so you can get some answers written down. This is time you can homework. So I'm just going to awkwardly sit here while you guys get some answers. Go ahead. Okay, then do it. What are you doing? Because it's asking us what's the chance that we would draw a diamond. How many diamonds? How many total? So we need to set a fraction with the amount of diamonds over total. We talked yesterday about how there's 4 suits, right? So diamonds is one of our 4 suits. So if we reduce that fraction, what's that fraction reduced to? The deck is split up even. And you know that you're holding your answer. It's not half, because diamonds are just these, right? It's a fourth, right? Because a fourth of your deck is diamonds. Writing it down. You're discussing drawing a diamond. We're discussing drawing a diamond. Here's somewhere on graph paper. 4 over 1. So there's a good chance of something happening, right? So how many of those things over the total? The total is going to have to be bigger. We're talking about a chance of happening. Back up to 3. Oh, I need you to tell me, Jimmy, why you wrote down what you wrote. If you guys were working together, you were working together. Can you like show him on your paper and say that slow? You see this paper? This is on the paper. So the whole deck of cards is 52. They're going to split it into fourths, like 4 pieces. They did. Whoever designed it had cards. Each of these sections has 13. With us. So, 13 are diamonds. There are 52 total. So the fraction growth, 13 over 52, is showing 13 is 52 total. But if you reduce that, or if you think just like, okay, if we look at just the A6, there will be just the A6, there's 1 diamond, 4 total. So that's how you got this reduced fraction of 4. Really, it's a fourth of the deck is made up of diamonds. Does that make sense? You can literally do something like drawing arrows and something. Here's some space for you. You put it on graphic.
What is your chance of being drawn right now? When I do this, who can explain? Reese, why are you saying, well, say it louder, and then why are you saying that? So this, the numerator, is always the thing we're looking for or talking about, versus what's the denominator always? No. Total. Always the total. Definitely not always the same. So your chance right now is 1 out of the whole deck, right? So, Reese, what's your chance right now? You said 1/12. So I draw a card. Now, what's your chance? Yeah, but Jimmy gets to answer our first question here. So, Jimmy, talk to me about drawing a diamond. What's our chance at drawing? And I forgot I have these up here, so I can leave. What's our chance at drawing a diamond?
13 over 50.
Yeah, where'd you get that 13?
There's 13 cards in there.
Yeah, there's 13 cards in every suit, right? So we have 13 of the diamonds. And then the denominator, we said, is always the total. How many total cards in the deck? Careful, switch those. Yeah, 52. Your brain just switched those numbers around. And then if you reduce it, or think about there's only 4 suits, this reduces to what? Anyone? 1/4. So there's our answer for A. And what percent is 1/4? Especially if you have that paper that is going to be worth candy next week. Anybody, what percent? 25%. Lakin, what about roll a number less than 5 on a single number cube? Guys, be careful. That's not this. Single number. This is for 2 dice, right? What's on this paper? Single cube. You got to be careful. Single cube. So if we look at just a single cube. Lakin? Yeah, we're not allowed to use 5. It's got to be less than 5. So 1, 2, 3, 4. Right? There's also 5 and 6. Those don't work. So what's 4 or 6 reduced to? And then as a percent, though, it gets a little weird. Yeah, guys, your calculator's lying to you. Grab a calculator, type in 2 divided by 3. At every table. Grab a calculator, type in 2 divided by 3. That last number is not true. So grab a calculator, type in 2 divided by 3. I thought there'd be one in your bed, but apparently somebody's already did it. So the decimal is 0.6 that repeats forever, actually. But we can round it up and say it's approximately 67%. If I've drawn 2 cards already, right? We had Jimmy and Lakin. If I've drawn 2 cards already, what is, if your card hasn't been drawn, what's your chance now?
A 10% chance.
1 out of 10, right? Because I've already gotten rid of 2 of these. I don't know where I put them. But yeah, so Elias Drawing a blue marble from a bag of 18 marbles, 3 of which are blue. What is our chance? Like, how do we set up the fraction for chance of getting a blue marble? What are you thinking? Chance of getting a blue marble. Elias, you got any thoughts? I'll try to help you along here. So remember, what we're talking about goes on top, total goes on bottom. Right? So our probability of getting blue here. So how many blues are in that bag? Can you read from back? I mean, it's on your paper too. How many blues are in the bag? 3. Yeah, it tells us right there. 3 blues in the bag. Good job. How many total? 18. That's literally all we did. We say how many blues are there, look in the problem, figure it out. How many totals are there? You want to go ahead and write that down since I don't know that it was already written down yet? What would this reduce to? Can 3 and 18 both divide by something? They can both divide by 3, which gets us, I know why, you said 6. Gets us to 1/6. Type that into your calculator. It's cool. Trust me. Type 1 divided by 6 into your calculator. This is a coincidence. This is not a rule. It's a coincidence. 1/6 becomes 0.166. That is not a rule. Like 1/7 is not 0.17. 1/8, like this is not a rule. It's just kind of cool. But what would this be as a percent if we round? We got to move that decimal how far? Jackson, what do we do with that decimal? Yeah, we move it 2. So what percent? I mean, we can round it. What percent are we going to say? Careful. Only 2 places. Ooh, yeah, just 17%. Questions on this. There's a quiz next week that has this on it. What questions do you have right now? Why? Because I need to assess learning. All right, so standard deck of cards, no aces, no 2s. Can anyone talk to me about what this does to like every problem we're going to talk about here? Liam? It removes 8 cards, right? Take away 8 cards. So now, how many do we have in the deck? How many did we have? Full deck is how many cards?
52.
52. Take 8 away.
44.
Okay, so we got 44 cards now. Right, that's our total. You might want to make that note on your paper if you haven't done this problem yet. I want to make the note that now we only have 44 total. Caroline, when we go to look at our chance of getting a heart, remember we took away our aces, all of them, right? We took away our 2s, all of them. So what's our chance of getting a heart? So 11 over 44. Because, guys, there were 13 hearts. In here, there's 14 hearts. But there were 13. Take away the ace, take away the 2. Now there's only 11 hearts. And there's only 44 cards. What's that 11/44 reduce to? Anybody? A fourth, and what is that as a fraction? Or a percent? Questions? Guys, I might ask you these exact same problems on the quiz. Like, seriously, taking stuff right from your homework is a fun trick I like to do, especially second half of the year. Because if you do your homework, it's like a reward. You did your homework, you know the quiz answers. You didn't do your homework, kind of like a, you know, punch in the face or whatever you want to say. Like, oh man, I should have done that. Maybe I'll learn my lesson someday. Probability of black. Reese, help me out. How many of those still remain? Wait, hold on. A. Wait, with a full deck, what's your chance of getting a heart? In a full deck, it's still 25%. Can anyone talk about why this is the same? Why didn't it change, Clayton?
Because the deck is split into fours, so every suit has a 45% chance of getting wrong.
Yeah, you can see that the deck is split into fours. This is why I like this printout. Guys, essentially, they like folded their paper and they said, okay, goodbye aces and twos, but it's still split into fourths. Or halves, depending on how we look at it. So, Reese, when we talk about the probability of black, what are you thinking here? It's still gonna reduce to, because Reese said 22 over 44. What's 22 over 44 reduced to? 1/2, because still half the deck. Taking away those aces and twos seems to have not changed the chance of a suit or the chance of a color. All right, chance of a face card. Josh, help me out. Chance of a face card.
So a chance of a face card,
How many face cards? Did the aces and twos, did that mess up my face cards?
12 out of 44.
12 face cards. Right, so how many face cards do we have? And then our total, be careful, is still just 44. Right, Josh said it right, but be careful. It's still just 44. What could both of these divide by? Like, we know it just because, like, right away, we know they could both divide by 2, right? But then if we think deeper, yeah, they could divide by 4. I'm just going to go slow. I'm just going to divide by 2 to start. So 6 over 22. I can divide by 2 again. 3. Type this into your calculator. This one's fun. Yes, I'm a nerd. They're all fun. 3 divided by 11. See what number you get there. Again, do not trust that last digit. Guys, it repeats 27 forever. It's kind of cool.
Wow.
But so what percent? Hey guys, if you're not comfortable with this yet, this is why we're practicing. To get the percent, your decimal moves twice. So what's our answer here? 27, like ish if we're rounding, right? 27%. Anything divided by 11 actually repeats. There's a fun trick with that we'll come back to later. I'm curious about what they were going for with D. Anyone think about... So wait, how is P of a face card different with this deck? What's our regular chance of a face card? Did we do that yesterday? Check what, like, did we do regular chance of a face card yesterday?
I don't think so.
No, you're fine. I was just checking if it was on the paper. Guys, look up in 24. What's the regular chance of a face card? Look at your problem 24 on your paper. You should have it from yesterday. What is the regular chance of a face card? Did we figure out the percent of that one? Of the 12 over 52?
70. 24.
So wait, we said 12 over 52. This was how many percent? Yeah, if you need to, punch that in a calculator. What percent was it? 20... Sorry, so I couldn't hear you. 23. So guys, which is better? Which percent is higher? 23 or 27? 27. So for D, what they're asking there is like, well, how do we compare these? Well, it got a better chance because we took some out of the total. Right? When you make it smaller, guys, think about this. Compare if this is your class, right? And this is my next class. In what class would you have a higher chance of getting picked? Your guys's. Because why? Why is it more likely that you get called on than somebody in my next class, Owen? We're a smaller class. When your total gets smaller, it ups your chance, right? So here our total got smaller. Between yesterday, today we messed with the deck, and we got smaller. What was that vocab word we learned yesterday about the not chance? Because you want to write it on your paper to remind you. What was that vocab word about the not chance? Complement, right? This is the complement. It's the chance that something doesn't happen. Here, with our modified deck, what's our chance of not getting a heart? Jackson.
75%.
Give me fraction first.
3/4.
Give me unreduced fraction first.
6/8.
More unreduced. It's 33 out of 44, right? Because there are still 33 not hearts. Because there's 11 hearts. And as Jackson said, that reduces to 3/4, which is 75%. Questions on what we did today so far? I got a couple minutes left, I think.
Yeah, 3.
We can still do a couple more problems. Mean. Guys, I'm not going to do this with you, but I'm just going to remind you. Mean is another way of saying average. If you need to look up the formula, do it. If you need to look up how to do average, you add them up and then divide.
Wow.
And median, who can remind us what median means? Yeah, just go ahead.
Middle.
When you line them up in order, median is middle. You might want to write down those notes if you can't remember what mean and median mean. What they mean. Area formulas. Hey friends. I have posters for a reason.
Holy crap.
But also you have the internet, right? So if you didn't know how to find the area, the trick is you got to know what the shape is. What do we call that shape on the left? It's not a rectangle. It's not a trapezoid.
A rectangle.
Notice how it looks like a rectangle, but somebody scotched it
A
sideways?
quadrilateral.
This is a parallelogram. Hey, you don't have to draw this, but I need you to listen. A parallelogram is really cool, though. Just check it. Imagine your parallelogram, right? I put the magnets a little off, but imagine your parallelogram. Okay, you with me?
Yeah.
If you cut off to make this side look like a rectangle, I can move this triangle, put it over here, and now we made what? Not a square, we made a rectangle. So if you imagine that we could cut this off, move it over here, and make a rectangle, our formula here, our formula is the same as when you have a rectangle. Area here is base times height. You might want to write this down. I'm not doing it for you, but area here is base times height. How's the triangle different? It still involves base times height. How is the triangle different? Area here is base times height, but then we have to,
Multiply by
ooh, careful, divide by 2. Hey, but the trick here, and this is the last thing I'm teaching you today. The trick here, your base and height have to actually be square to each other, because if your base is the bottom, then your height has to come straight up from it. This triangle's upside down. That's our base, and the height coming straight up from it is what? What's the height coming straight up from the base? It's actually going straight down, kind of.
9.
9. You might want to highlight those so you remember later that's your base and that's your height. Clip this somewhere safe.
Mr. Hudson.
511 and 512 were due yesterday. If you have them, turn them in, and 521 as soon as it's done.
Miss Heather wanted to have a couple more minutes. She said something because it's
Hey, you have a couple more minutes to work on your homework. Don't put it away yet. Turn it like start. Ooh, hold on. Let's do an order of operations problem. Here, look further down your page. Let's practice order of operations. Thank you, Mrs. Pecker. I appreciate this.
Yeah.
Hey, so look at 33. Start, like, turn to a neighbor. Say what you think we need to do first. Order of operations. PEMDAS. Do I need to go ahead and send Elijah? Yeah, you should probably pack up over to the office. She's got a meeting. I lost my deck of cards. Jimmy, what do you think we do first? What's that P stand for? That's not what we do first, though. I mean, that's what we say, but what's the P stand for? What's it stand for? Parentheses. You might want to write this down to remind yourself. Hey guys, literally on your paper, you could put PEMDAS like this in the middle of these problems to kind of separate like the left ones from the right ones. You only do what's in the print. Hey guys, if you're trying to do a bunch of this, like skipping steps, you're going to make a mistake, I'm telling you. So we start by only doing parentheses, but you can do both at the same time, like both parentheses. What's 8 minus 4?
4.
And then what's 2 plus 3?
5.
Yeah, so we can do both of those. What, Major, does the E stand for? Nope. Guys, this is why we're practicing this. What's the E stand for? Exponents. So Major, maybe don't just turn and talk to Josh about how funny that was. Maybe listen. Exponents. If you need to highlight this and write this down, do it. E for exponents, that's an exponent. Our exponents are used to tell us what? Like, what is 4 squared telling us to do?
4 times.
Yeah. How many times you multiply by itself. So if you need to make a note that 4 squared means 4 times 4, and that's an exponent, maybe make that note. So I'm going to leave. I don't do anything with that. I only do my exponent. 4 times 4, what is it?
16.
So there was my E step. With me? Makes sense now? E for exponents. Guys, this is why you've got those others to practice. Use my answer key. Right? I go step by step on my answer key. If you want to go check it after you do it, but really, you need to try it on your own first. Clayton, what's the MD stand for? Multiplication, division happening at the same time. Do we have any multiplication or division? Yeah. So let's do it. What is the multiplication up here? 3 times 4, so that gets us, that's the only thing we do. Oh, and what's the AS stand for? Addition and subtraction. And we always have to do it working left to right, just like how we read. It does make a difference. It won't always, but sometimes it'll get you the wrong answer if you don't work left to right. So what's 12 plus 16? 28, and then we can do minus 5. What's 28 minus 5? 23. I would just bump directly over and try that next problem, like with your partner, while we're waiting to see if Pettigrew is ready. Hey, these are mine for now. Please leave these on the table. They're going to be for the next Math 7 class. But if you need one, like if you can't remember this stuff and you need one, that's fine. Just come tell me. All right, pack it up, head on out. Have a great day, guys. Can you maybe try to motivate yourself over the weekend? Because you're making me get real depressed. You're at Phoenix. We have high expectations. live up to them, or go to school somewhere else. Like, I don't know. Like, sorry, to put it bluntly, do your homework. No, because I'm still in the process of writing it, but it will have